I am Mikhail Polyakov. Together with my colleagues, I present a report on the topic modeling and programming of elements of integrated systems in industrial controller languages. An element of integration between subsystems within the control hierarchy is the complex of controlled and control automata. The lack of models and methods for programming such a complex in programming languages according to the IEC 61131 standard is an urgent unsolved problem. Purpose of work is to develop a methodology for designing standard elements of integrated system with software implementation of control algorithms in languages of IEC standard. The finite state machine model, known since the time of Viktor Glushkov, is simple but does not provide the structural adaptation of machine during its operation. The model previously proposed by the authors makes possible to change the trajectory of state changes during the operation of the system and thereby implement the structural adaptation of the automaton. However, such an automaton does not form an integrated system. Known models of an integrated system element don't cover the implementation of this element in an application programming environment in the languages according to the IEC standard. This languages is ladder diagram, function block diagram, sequential function chart, structured text, and the instruction list. Of well-known programming environments, the authors choose OpenPLC because it is a freely distributed program, supported all 5 standard languages, and allows you to load code into boards with microcontrollers. By a controlled automaton, we meet an automaton 1, which with help of another automaton 2 can change at least one element of its tuple. Management goals can be the following: changing the number of control cycles, structural and parametrical adaptation of control unit, reduce the time to reach a rational control cycle, changing impacts of the control object by nomenclature, amplitude, time interval. Typic control change trajectories provide exponential narrowing of functionality, increasing the number of stages in control cycles, increasing the number of unclocked input of the low-level machine. Block diagram of a typical element of an integrated system is shown on slide 6. The diagram shows control automata of the first and second level, input and output operational automata of the first and second level, and the system control object. The inputs CIOA1 and COOA1 control the parameters of the operation automations, and the inputs C sub X, CS, CS1, CSL control the structure of the CA1 automaton. All of these listened control signals are generated as outputs of the CA2 machine, which also has similar control from the overlying machine. The selection of program organization units for implementing automaton is shown on slide 6. These are function blocks and program in the language SFC FBD, LD, and ST. In the experimental part of the work, a typical element of an integrated system was studied. Graphs of the controlled and controlling automaton on this element are shown on the slide 7. The automaton SA1 have 5 states, 8 inputs and 5 outputs. More the other, output 0 is active in state 0. Output 1 is active in state 1, and so on. The parts of 4 cycle of system control object pass through the state 0 on the automaton SA1. This is part 1, 0, 1, 3, 4, 0, part 2, 0, 1, 4, 0, part 3, 0, 2, 3, 4, 0, and part 4, 0, 2, 4, 0. The control cycle changes when activity passed through the state 0. The control strategy is to move the activity of machine in the sequence part 1, part 2, part 3, part 4. When the sequence is repeated again, the control strategy is formed by automaton SA2, and in which there is only one part 0, 1, 2, 3, 4, 0. The state change on this part occurs at the moment of completed of the next cycle of the automation SA1. Graphical FBD representation of typical element of integrated system program for graph slide 7 is shown on the left side of slide 8. This program contains functional blocks of automata SA1 and SA2 and the control block of control logic. SFC functional block of SA1 machine is shown on the right slide, on the right side of slide 8. SFC function block of SA2 machine version 1 and version 2 and ST function block cont for controlling the inputs of the SA1 machine are shown on the slide 9. Testing of the developed project for a typical element of an integrated system was carried out both using the built-in debugger on the OpenPLC editor application and by transferring the project code to the Arduino board. The test results confirmed the functionality of integrated system declared in the project, such as management the cycle of actions and the system and management in the system and managing the typical sequence of changing control cycles. The main conclusions from the work are shown on the slide 10. The proposed methods for controlling the parameters of operating and control automaton as part of a typical element of an integrated system expand the functionality of adaptive behavior in the system. The practical value of the proposed methodology for implementing adaptive behavior lies in the possibility of using typical elements of an integration system implemented in the programming languages of industrial controllers. Thank you for attention.